Hey guys, welcome back to the Pre-Calculus 20 video lessons. In this video today, we're going to be looking at an example from Chapter 2, Lesson 2, which is talking all about trigonometric ratios of any angle. Now, before we get to the example, we first need to do a quick recap on what we learned in our lesson. So the first thing that we talked about was if we had a point P of xy, and we had it, say, on your Cartesian plane. So when we're looking at our picture over here, you notice that if we were to plot our coordinate and draw the vertical and horizontal distance, you would notice that you create a right triangle here. And one thing that we can do with right triangles is we can find either unknown angles or distances using the three primary trigonometric ratios, which are sine, cosine, and tan. So when you're also thinking about, say, the sine ratio, that is your opposite over your hypotenuse. So when we're looking at our triangle over here, our angle is always in relation to the x-axis, and it's going up to wherever that point is. So here we have opposite, and so the side that's opposite your angle, so pointing straight across, is that y value, and then our hypotenuse, which is pointing across from our 90-degree angle, is our r value. So this here is equivalent to y over r. Same thing that happens with cosine and tan. Cosine is equal to x over r, and tan is equal to y over x. And if you're ever having trouble, if you guys want a little neat saying like so katoa, you can use Sarcoxertics. So you have sine is equal to your y value divided by r. Then you have coxer, which is cosine, is equal to your x value divided by r. And then you have tix, which is tan is equal to y divided by x. So similar to SOHCAHTOA, we have Sarcoxertics. One thing that we also did a recap on was the cast rule. And so this one here just tells you whether or not your cosine or sine or tan is positive or negative depending on what quadrant it's in. So using the cast rule, you start in the bottom right corner and you literally spell the word cast going in a counterclockwise direction. So you have C-A-S-T. So that means in quadrant 4, cosine is positive. In quadrant number 1 here, all of them are positive. In quadrant 2, sine is positive. And in quadrant 3, tan is positive. So obviously, all the other ratios, if they're not positive, they have to be negative. Okay? And so we're going to be using both the cast rule and Sarcoxertics to help us out with our next example. So this one here is the first one from your notes. The point P, 12 and negative 9 lies on the terminal arm of an angle theta in standard position. Determine the exact trigonometric ratios for sine, cosine, and tan. So here what we're doing is we're going to determine the exact trigonometric ratios for sine, cosine, and tan. In this question here, we're also given that we have a point that's 12 and negative 9 on your Cartesian plane. So what I like to do first is I always draw a picture of the situation. So first I'll draw my Cartesian plane, and then just do a quick rough sketch. Don't pull out your graph paper and try to get exact. What we're going to do is we're just going to do a rough sketch. So here our x value is positive 12. And that's going to be really important to identify whether or not it's positive or negative. Because on the right side of our x-axis, all of your x values are positive. So it's positive x, and then we have a negative y. Looking at your y-axis, anything that's above your x-axis is positive, anything below is negative. So if we have positive x, we're going to be going out to the right, and then if it's negative, we're going down. So maybe your point P is going to be somewhere in our quadrant 4. Then what you'll do is, then you'll draw a line connecting your origin and that point P, and then you'll draw it connecting with your x-axis. So you're always going to draw connecting to your x-axis, whether or not it's on the right side or your left side. So here is point P. Then we can also label this. We know that our x distance is 12, so from the origin up into our x-axis, we have a distance of 12, and then our y value going straight up and down, that is negative 9. So now in order to do our sine, cosine, and tan, we have to have a y value, which is 9. We need to have an x value, which is 12, but we don't have that r value. So we need to find that hypotenuse of your triangle. So in order to do this, you need to use your Pythagorean theorem. You have two sides, and you're trying to find the third. So your first step here is to find your r value. So just to recap, remember with circocs or ticks, so trying to find your sine, cosine, and tan, you need to know your x value, your y value, and that r value. So if you guys remember, you guys can either use your Pythagorean theorem, or also, I also did give you the shorthand when we're trying to find our r value. So your r value is equal to, so it's your x coordinate squared plus your y coordinate squared, and that's all square root. So then we can just fill in what we know. So we know r is equal to, so it's the square root of your x value, which is 12. So we have 12 squared, plus your y value squared, which is -9 squared. Our next step then is to simplify our exponents. So first we can throw this either into our calculators if you guys know this off by hand. So you will first go 12 squared, which is 144. Then we can add with -9 squared, which is 81. We can simplify inside our square root by adding those two numbers. So we get the square root of 225. Now if we put that into our calculator, we would find that the square root of 225 is equal to 15. Now that we know r, now we can actually find those trigonometric ratios. So step number 2 is, we can first find our first ratio, which is sine of theta. Now using our little trick, we know that sine of theta is equal to your y value divided by r. We know our y value is -9. We know that r is equal to 15. So plug in what you know. So sine of theta is equal to -9 over 15. Now one thing that's really important here is that our question here wants the exact trigonometric ratios. So we're not going to turn this into a decimal form, but one thing that we can do is we can reduce this fraction. So what you'll notice that we have 9 and 15, and those are both multiples of 3, which means we can reduce by a factor of 3. So what we would get is we have sine of theta is equal to -3 over 5. And then with that, we can no longer reduce this fraction, so we would say that this answer here is simplified. Now we can move on to find our cosine, which would be step 3. So to find cosine, using our little jingle, circocs or ticks, we know that cosine is equal to your x value divided by r. So we're going to fill in what we know. So we know that cosine of theta is equal to x, which is 12, and your r value, which is 15. Once again, from there, you notice that we have 12 and 15, and those are both, again, multiples of 3, so we can divide your top and your bottom of your fraction by 3. So what we would find is that we have cosine of theta is equal to 4 over 5. And to do the last part of this question, I'm going to scroll down. And so now we're going to be finding tan of theta. So using that jingle, you know that tan of theta is equal to your y value divided by your x value. So plug in what you know. So you know tan of theta is equal to y, which is -9, divided by x, which is 12. Once again, these are both divisible by 3, so you can reduce that fraction. So divide the top and the bottom by 3. And what we should be left with here is tan of theta is equal to -3 divided by 4. Now, one thing that's going to be really important here is we can double check, I guess, our term in terms of our positive and negative symbols. So just go back and look at where your angle is. So in your angle here is in quadrant 4. So using your cast rule, you have C, A, S, T. So in quadrant 4, the only ratio that should be positive is cosine. So go back to your questions and just double check, are they in fact the correct positive and negative symbols there? So our first one here is sine. That one there is negative. Cosine is positive, and tan is negative. So it's not a great way to check, but at least it's a starting point, and can at least give you a little bit more security in your answer. So with that, we are all done this lesson. So thank you so much for watching.